Hey, welcome back everybody. So today is all about finding the distance between 2 points that are represented in polar coordinates. And we're going to do this in two different ways. And so in order to get there, we're of course going to need some tools. So first, expressing this point, remember that x is equal to r times cosine of theta. Y is equal to r times sine of theta. So I can express xy in exactly this way by this. We're going to need the cosine of the difference of angles formula. That's a classic. And then 3, we're going to need the law of cosines. Okay, so how do we do this? How do we get a polar distance formula? Okay, so let's say I've got 2 points. Let's say this point is r1 theta 1 in polar. And let's say maybe this point is, how about r2 theta 2 in polar? And we want the distance between the 2 points. So expressing this point in Cartesian, that would be, remember r cosine, but we want to say r1 cosine theta 1, comma r1 sine of theta 1. And expressing this point in Cartesian, this would be r2 cosine theta 2, and then r2 sine theta 2. So once this is in Cartesian, we can use the Cartesian distance formula, and our goal is to land at the polar distance formula. Okay, so of course we want to take the difference in the x values and square it. So let's see what we have here. So this is r2 cosine theta 2 minus r1 cosine theta 1, quantity squared, plus we want the difference in the y values squared. So that's r2 sine of theta 2 minus r1 sine of theta 1, quantity squared. So we've got a bunch of algebra to do here. Okay, so that's going to give me, looks like r2 squared cosine squared of theta 2 minus 2r1 r2 cosine theta 1 cosine theta 2 plus r1 squared cosine squared theta 1. And then we're going to square this. So that should give us r2 squared sine squared of theta 2 minus 2r1 r2 sine theta 1 sine theta 2 plus r1 squared sine squared theta 1. So let's see if we notice anything nice. Does this have a companion with a sine squared of theta 2? It does. That's nice. That makes me happy. And let's look right here. Does this have a companion with a sine squared of theta 1? And in fact it does. That seems nice as well. Okay, so let's bring those together. So this and this, I've got an r2 squared times cosine squared theta 2 plus sine squared theta 2. We love that. And then for these two, looks like r1 squared times, looks like cosine squared of theta 1 plus sine squared of theta 1. Now these terms seem interesting. Let's bring them together and factor out that 2r1 r2. And maybe we'll notice something nice. I see something nice. Do you see it? I see the cosine of the difference of angles formula. Okay, so by Pythagorean identity, that's 1 and that's 1, so that's nice. So many nice things. And then by the cosine of the difference of angles, that's the cosine of theta 1 minus theta 2. And since cosine's an even function, it doesn't matter which order we write these in, you get the same thing. And then we could just write this with the r1 squared first. That seems really nice. And here is our polar distance formula. So this will give you the distance between 2 points that are expressed in terms of polar coordinates. Okay, so that's method 1. I promised 2 methods. So how can we also find this formula using another method? Okay, so let's think about this. So what did we say? We said that was in polar r1 theta 1, and then in polar we said that was what, r2 theta 2? So r2 theta 2. Okay, and so we want the distance between this point and this point. Let's call that distance question mark, because I don't know what it is yet. Well, we do, but we don't. Okay, so we've got a triangle, and so the side of this should be, that should be r1, and this side right here should be r2, and this right here, this angle between, so I'm thinking side, angle, side, this angle between should be theta, and what's the right way to think about theta? Well, if this is theta, we could think about it as this whole angle here. This whole angle is theta 2, right? If that's the angle corresponding to this. So this is theta 2 minus theta 1. Let's note that. So theta is actually theta 2 minus theta 1. Okay, that seems pretty good. Pretty happy with that. And how about the law of cosines, right? We could use the law of cosines to find the missing side. That seems really nice. So by the law of cosines, we'd have the following. By the way, there is a proof of the law of cosines on the channel. Scroll down, it's worth it. It's a good one. It's a classic. Okay. Okay, so the mystery side squared, that's what we want to find the length of that. That is equal to, so this side squared plus this side squared minus 2 times the product of the sides times the cosine of the angle between. So we can just take the square root. And so question mark equals the square root of r1 squared plus r2 squared minus 2r1 r2 cosine of theta. But what is theta? Well, theta is exactly theta 2 minus theta 1. But if we want to write it in terms of what we had before, we know since cosine of negative x is equal to the cosine of x for all x's, that means that cosine of theta 2 minus theta 1 is exactly the cosine of negative theta 1 minus theta 2, which is exactly the cosine of theta 1 minus theta 2. So yeah, we can actually go ahead and rewrite this. So I've got r1 squared plus r2 squared minus 2 times r1 times r2 times the cosine theta 1 minus theta 2. And again, that is our polar distance formula. If you give me 2 points that are expressed in polar coordinates that will measure the distance between the 2 points. Super cool.